Okay, here's my solar setup. This is the inverter, and it's got a 125 amp breaker here, and currently it's running for a fridge, pulling still 4.47 amps at 48 volts. And here, I don't know why it's so hard to see, 300 watt, 330 watt. Okay, and so here the charger is delivering 13 amps into the battery, and out from the battery goes 4.3 amps. The opposite direction, obviously it's the same. Here the AC to the fridge, 2.5 amps, which is currently running. I hear the compressor running. Okay, so now we're going to do a fuse shut-off test. Firstly, we have to say that, let's see how we can put this into focus. This here is a 50, I think it's a 50 amp, yeah, here it says 50 amp fuse, breaker. And this here is from the solar panels, obviously, and it's bringing in, it has I think it's a 10 amp breaker. Yes, it says here 10 amps, right? Now this one is an unpolarized breaker, and let's see how much it currently delivers. Let's see, we have to get back to amp DC current, okay, and then we can see here what it currently delivers, and we have 7.4 amps at some kind of 100 volts probably. Okay, and so the issue is here, this is a breaker, this is a polarized breaker, while this one is not a polarized breaker. So it's easier to install because there's not a particular direction you have to go. This one is polarized, meaning in order to extinguish the spark or the arc when it disconnects, you have to route the cables in a specific way. And the way this is being indicated here is that when you come from above, so when the source of the power is from above, then you have to put the positive side on here. But since and when the power comes from below, in this case from the battery, then you would have to put the positive side on this end. Okay, now that's all nice and good. The problem is that in the battery case, it actually goes both ways. So I'm not really happy that I'm not happy with this breaker at all. First of all, if it was actually delivering full power charge to the battery, it would be a lot more than 10 amps that it currently is, or 15 amps. It would be more than 50 amps. It could be as high as 100 amps. Okay, so that's why this is already too small. However, it's not really too small because the way my solar panel configuration will never allow anything more than, 10 amps come in here, and so it would be at most 30 amps coming out. So actually, this is not too small as it is currently configured with the solar panels. There's no way it could deliver more to the battery. But the direction is still the question. Which direction will I put this thing in? And if there was like 100 amps going in the wrong direction and it switches off, then there is some video, I might link to it, that says there is it would result in a fire, pretty bad actually. However, I have here a smaller one, but it doesn't matter right now. But the issue is that which direction should I go? And I decided to actually put it in the direction where the source is the battery, because that's really the bigger danger. The battery has unlimited current capacity. I mean, almost virtually unlimited. I think it could deliver 200 amps or 300, 400 amps without whatever, right? It could deliver that. And whereas this one, the box here is limited by what the solar produces, right? So, and it will not produce more than what 100 amps. So we're okay on this. However, where's the risk from what requires a breaker anyway? Well, I'm thinking that it is that something is breaking here, like the end stage of this power supply, whatever. There's some power FETs or transistors, whatever, which could for some reason short out. So if something shorts out here, then full power would be delivered from the battery. So I believe that in the worst case scenario, the battery is the source and this is the sink. So that's why I have installed this breaker in such a way that it is correct for that direction of flow. However, now the battery is being charged and we can have a little check up on what the current situation is here. Currently we have 13 amps going in to the battery, so that's significant. But it's 48 volts, so it's probably not that big of a deal. So what we're gonna do now is we're gonna shut this off. Actually, I'm gonna do this a couple of times because I want to see I want to be safe right now, right here. If a problem arises, it's best to arise right here before I install it all nicely on the wall and denser, because I will put this breaker obviously on that same rail. So let's do it. Boom. Okay, that's good. Nothing happened. I didn't hear any hissing or sizzling or nothing. So let's turn it back on. I don't know if it's so great for the battery to be turned off and on all the time, but let's do another 5 times. No problem. Turn it back on, but also obviously have to check the current. It's again 13 amps. Boom. Okay. So back to checking. 13 amps. Boom, check, 0. And still 4.3 amps coming out of the battery. Any smell? I don't feel any smell either. So I'm gonna do the last test now. Again, 13 amps to the battery, and boom. No smell, no nothing. So I feel safe and happy now. So I think this is going to be fine. There's not going to be any problem with breakers catching fire. Okay, so this is my little setup. I guess I will leave a last comment that the battery obviously was the most expensive one in Brazil. Gosh, this was like 9,000 reais, which is like what? Divided by 5 to get the dollars. Everything is twice as expensive here. This charge controller I got, I think, used or refurbished from eBay and got it shipped to Colombia and then brought it to Brazil by travel, which made this one, I think, was just a $500, which is actually a pretty good price for this charge controller. And this one, I was really happy. That is a 3,000 watt inverter, 6,000 watt peak. So it's actually pretty powerful inverter. And I got this used here in Rio de Janeiro, and it was like 800 reais, which is really not much. Divided by 5 again, so it's $120. So it's actually a pretty good price for a 48 volt. It's difficult to get 48 volt stuff like inverters. 12 volt obviously it's easier, but they would need super fat cables. So I'm happy with 48 volts, especially because this is intended to go into the Amazon. So Starlink runs on 48 volts too, so it will be connected to the DC arms here instead of going through the inverter. The inverter itself is actually pretty thirsty. I'm still trying to figure out exactly how much the inverter uses on idle, but right now I have my fridge connected to it, which is pretty much the situation that it should have in the Amazon as well. So I just want to see how that goes for a couple of days, and then I will take care of that question about the idle charge, the idle current on this inverter. And the other thing is that this charge controller, in order to automate this and to monitor it correctly, it has a CAN bus connector, and the inverter has a RS 485. Okay, RS 485. So two different. And then this one, I was hoping that it had at least an RS 232, the battery that would have had at least an RS 232 connector, because it has actually an electronic battery management system with some stupid big ass display, which is telling me now that the battery is full. But I actually need to have this in some microcontroller as some input. So I'm very disappointed actually that this expensive battery does not have any kind of connector, and not Bluetooth, no connector, no nothing, in order to understand all the data that it collects in its battery management system, which is certainly a lot. And that's really sad. So what I'm almost thinking about is just voiding the warranty, open the thing, look at the board, the battery management board is somewhere in here, and on top I could just take it out, and I'm sure there's a microcontroller, and I'm sure it actually has communication capabilities. They're just not let out. I've been talking with the vendor and they say no, but I guess it's something I could still do before I take it to the Amazon. So there we go. That's it. The breakers are good. They're okay. I can trust them now. Can I trust them to actually do break when there's an overcurrent condition? Well, I can't test that because I don't want to do it short. I don't want to short it now. That could become a mess. So I'm just, I think the breakers will work. And the other thing is, the breakers are they really necessary? That's a question, right? I guess the big issue is the battery. You don't want to have this excessive amount of current coming out of the battery if it's wrong. So here we go. That's the end.